This video, we are going to give an introduction to trigonometric functions. These are exercises from section 3.4 of the Apex Pre-Calculus textbook. I already gave a slight introduction to trigonometric functions in when we did our library of functions video. So hopefully some of this will be a refresher for you, but we'll talk more about that. I might spend a little time talking about the unit circle, though I think that's covered more in depth in section 3.5. Explain why the domain of tangent is restricted, because tangent is equal to sine over cosine, and there are zeros of cosine. Cosine graph looks like so, as a wave that has zeros at pi over 2, 3 pi over 2, comes down again 5 pi over 2, negative pi over 2, negative 3 pi over 2. So it's undefined at all the odd multiples of pi over 2, because those would be zeros of cosine that would make the graph undefined. So the tangent graph looks like this: negative pi over 2, pi over 2. It's bounded between there. It's positive over here and negative over there. Tangent has to do with slope. So the pieces that are in that are between 0 and pi over 2 here have positive slope. The pieces between 0 and negative pi over 2, those lines would have negative slope, tending towards, this tends towards infinite slope in a negative direction. This tends towards infinite slope in a positive direction. So, and then it's just going to repeat itself, that over here is going to be pi, and we're going to have 3 pi over 2 over here, and then it's going to repeat like that. There's another cycle over here at negative pi and negative 3 pi over 2. It's that asymptote, and it just cycles forever like that. Explain why the domain of cosecant is restricted. So cosecant is equal to 1 over sine of theta, so reciprocal of sine. So the zeros of sine are going to make cosecant undefined. Sine looks like this, and it's a wave that keeps going forever in both directions. So it's got zeros at 0, at pi, at 2 pi, all the multiples of pi, it has zeros, negative pi, so on. So those are the places where cosecant is undefined. So we have pi over 2, we have pi, we have 0, we have negative pi over 2, we have negative pi, we have 3 pi over 2, we have 2 pi. Okay, that should give me enough. So at pi over 2, it was 1, the reciprocal of 1 is 1, and I am up here in this piece. At 3 pi over 2, I'm at negative 1. Reciprocal of negative 1 is negative 1, and I'm down here in this piece. I don't ever cross the x-axis in this graph, and then it just alternates above and below, like so. And then we're back above again, and it's always 1 and negative 1 are the places where it starts going up at 1 and it starts going down at negative 1. What do the coordinates of the unit circle tell you? Oh, good, we are going to talk about the unit circle today. So the unit circle is a circle with a radius of 1. That's what it means by a unit circle. And that any coordinate on the unit circle is going to give us, if this is theta and this is x and this is a y and this is 1, then x is going to be equal to the cosine of theta and y is going to be equal to the sine of theta. Take a look at that and see that cosine is x over 1, so x is cosine. Sine is y over 1, so y would be sine. So we can read the unit circle and we can get cosine and sine values. That helps us to get tangent values, cotangent values, secant values, cosecant values as well. There are two main trig triangles that you need to know that we stack around to make the unit circle. And they are the 30, 60, 90 and the 45, 45, 90. I'm going to adjust them a little bit though, so that normally we would have the 30, 60, 90. So that this side is 1 and this side is √3 and this side is 2. I don't want to do that. I want the radius to be 1. So I'm going to divide everything by 2. So this is going to be 1/2 and this is √3 over 2. So my ordered pair out here is going to be √3 over 2. 1/2, the sine of 30 degrees is 1/2. The cosine of 30 degrees is √3 over 2. If I shift that triangle so that I have the 60-degree angle in the lower left-hand corner now I have √3 over 2. I have 1/2 and I have 1. And this point up here is going to be 1/2 √3 over 2. So we're going to see for these complementary angles that the sine and the cosine are going to switch positions. Then I have one last one. I have my 45, 45, 90. Normally I would write 1, 1, √2, but I'm not going to do that. I'm going to divide everything by √2 so the radius is 1 again. This is 1 over √2 or √2 over 2 and √2 over 2. So this point out here on the unit circle is going to be √2 over 2, √2 over 2. So those are going to be my important positions. I'm going to draw my entire first quadrant of my unit circle now that I've shown you that this is my 30-degree angle, my 45-degree angle, my 60-degree angle, and I'm going to have 0 degrees and I'm going to have 90 degrees. So at 30 degrees here, I have √3 over 2, 1/2. I have √2 over 2, √2 over 2. And I have 1/2 √3 over 2. Over here, I have x is 1 and y is 0. And up here, I have x is 0 and y is 1. Everything off of the circle is going to be reflections at that point to get into quadrant 2, quadrant 3, quadrant 4. You just need to memorize quadrant 1 and you'll have all the numbers. You just are going to need to change the signs based off of what quadrant you're in. Pay attention to what's called your reference angle, which you're going to have here in quadrant 1. Now, if it's hard for you to remember all this, let me show you a little trick to remember. They're always going to go over denominators of 2. So, and the trick that I'm going to show you is to take your left hand and trace it. And I don't have enough paper to do that. So I'm just going to pretend that I'm drawing my left hand here. Okay, like that. So that this finger here, your pinky finger, represents 0 degrees. This one is going to represent 30 degrees. This one 45 degrees. This one 60 degrees. And this one 90 degrees. They're not really those degrees, but just those are your important angles. So when I put a finger down, I'm going to look at what's to its left and what's to its right. So at first, I'm going to do something easy. I'm going to put down my middle finger and I'm going to look and I have my pointer finger and my thumb to the left. So I have 2 to the left and I have my ring finger and my pinky finger to the right. I have 2 fingers to the right. So it's the square root of 2 is the number of fingers that I have to the left over 2. And square root of I have 2 fingers to the right over 2. And that's what my point is for my ordered pair at 45 degrees. is root 2 over 2 and root 2 over 2. So now I'm going to try 30 degrees. I'm going to put my ring finger down, and I have 3 fingers to the left. So that's going to be root 3 over 2. And I have 1 finger to the right, that's root 1 over 2, but root 1 can be simplified. So that's going to be 1/2. I'm going to try my index finger. Now I'm going to put that down, and I have 1 to the left, that's my thumb. So I have 1/2 to the left, and I have 3 to the right. Now we're going to try something that is harder to think about, but that's okay. I'm going to put down my pinky finger, and I have 4 fingers to the left. Root 4 is 2. 2 divided by 2 is 1. I have no fingers to the right, so that's root 0 is 0. 0 over 2 is 0. And see, I'm getting the correct coordinate pairs every time. And if I would do the same thing with my thumb, it would switch positions, that I would have root 4 over 2 is 2 over 2 is 1 on the right, and I'd have 0 on the left. And there's how I can find all of my coordinates on my unit circle with what I call the left-hand trick. You can find a YouTube video on this. This is where I learned it from. Just search in YouTube, right or unit circle left-hand trick. And there will be a video of someone actually showing this and putting their fingers down and teaching you how to memorize the first quadrant. Once you've memorized the first quadrant, everything else is going to make sense after that. Okay, now sketch a unit circle from memory. So circle quadrants, let's put our quadrantial points first. That's 1, 0, that's 0, 1, that is -1, 0, and that's 0, -1. Now I'm going to have to make my first quadrant here. This is root 3 over 2, 1/2, root 2 over 2, root 2 over 2. This is 1/2, root 3 over 2. Now this is going to be 30 degrees, 45 degrees, and 60 degrees reference angle in quadrant 2. So this is negative root 3 over 2, 1/2, because it's negative x positive y, negative root 2 over 2, root 2 over 2, negative 1/2, root 3 over 2. And I'm going to come down here, 30-degree reference angle, 45-degree reference angle, 60-degree reference angle. 30-degree reference angle, we're going to have both x and y negative, root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2. Then we're going to have negative 1/2, negative root 3 over 2. Now I have 30-degree reference angle, 45-degree reference angle, 60-degree reference angle in quadrant 4, where x is positive, y is negative. So this is root 3 over 2, negative 1/2. This is root 2 over 2, negative root 2 over 2. And this is 1/2, negative root 3 over 2. Now I need to fill in the angles here. I've mentioned the angle measurements as we went around. This is going to be 30 degrees, 45 degrees, 60 degrees, 90 degrees. This is 120 degrees. This is 135 degrees. This is 150 degrees, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees. Then we're back to 360 degrees. You can do negative angle measurements as well. I'd also like you to pay attention to, this is pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2 radians. This is 2 pi over 3 radians. This is 3 pi over 4 radians. This is 5 pi over 6 radians, pi radians. This is 7 pi over 6 radians. This is 5 pi over 4 radians. This is 4 pi over 3 radians. This is 3 pi over 2 radians. This is easier for me to do it this way, 11 pi over 6. This is going to be 7 pi over 4, and this is going to be 5 pi over 3. Again, you can come around in a negative direction. Make sure you learn it in radians. Is going to be very important because we're going to use radians more often than we're going to use degrees. It's okay to use degrees first, but make sure you learn your unit circle in radians for your angle measurements as well. Figure 3.2 in the textbook here is going to give you the entire unit circle. So let's go check ourselves up here. Here it is, and they give it to you in degrees and in radians, and they give you all the key points around there, okay? So that is very important for us as we study trigonometry to have our unit circle memorized. Though, do not depend completely on your unit circle. It only helps you when your radius is 1. Also, when you get to physics class, you're going to need to know those trig triangles that I showed you, because everything in physics is based off of breaking vectors up into components, and you need to be able to draw these triangles so that you can do your force diagrams in physics. The physics teachers usually do not like the unit circle because it doesn't help you see the triangles that you need to break things up for with vectors. So we do our best at Reynolds to teach the right triangle approach, not the unit circle approach to pre-calculus. But when you get to calculus, it's okay. We're going to expect you to use the unit circle because you have already learned it. Okay, so evaluate each statement now. Tangent of pi over 4 radians. Pi over 4 radians is the same as 45 degrees. The tangent is going to be the sine over the cosine, and they equal each other there, so the tangent is 1. Cosine of negative pi over 4 radians, so this is going to be the same as the cosine of negative 45 degrees. Cosine is going to be positive in quadrant 4, so this is going to be root 2 over 2. Sine of 3 pi over 4. 3 pi over 4 is in quadrant 2. The sine value is positive there, so that's root 2 over 2 because it has a 45-degree reference angle. The cosecant of negative 3 pi over 4 is going to be 1 over the sine of negative 3 pi over 4. Negative 3 pi over 4 is the same as 5 pi over 4. I am in quadrant 3, and my sign is negative there. So this is 1 over negative root 2 over 2, but root 2 over 2 is the same thing as 1 over root 2. So this is the reciprocal of this, is going to be a negative root 2. Sine of 3 pi over 2. 3 pi over 2 is one of my quadrantial angles. I'm not going to be able to draw a triangle for that. And I should have drawn triangles for all these. Let me go back and do that. So pi over 4, here's my special right triangle. and I have 1, 1 square root of 2, and my tangent is opposite over adjacent. So tangent of pi over 4 is going to be 1 over 1 is 1. Cosine of negative pi over 4, this is tangent of pi over 4. Negative pi over 4 is going to give me a pi over 4 reference angle here. And this is going to give me negative 1, 1, root 2. My cosine is going to be adjacent over hypotenuse. So I'm going to rationalize and make that root 2 over 2. Sine of 3 pi over 4. 3 pi over 4 is in this quadrant. So I have a negative 1, a positive 1, and a root 2 for my reference angle. Sine is going to be 1 over root 2 is going to give me root 2 over 2. Cosecant of negative 3 pi over 4, negative 3 pi over 4 is down here. I went this way to get negative. So here's my triangle that I'm talking about. It has a pi over 4 reference angle here, negative and negative. It's negative 1, root 2. Cosecant is going to be the reciprocal of sine, so it's hypotenuse over opposite. So this is root 2 over negative 1 is a negative root 2. Sine of 3 pi over 2, that can't be formed as a triangle because it's a quadrantial angle right there. So I'm just going to look at the unit circle to tell me my cosine is 0, my sine is 1. Sorry, my sine is negative 1 because I'm below the x-axis. There we go. Cosine is 0, sine is negative 1. Determine the range of each function. I didn't answer what is meant by the range of a function up here, but the range of a function is all the valid outputs. So f of x is going to be equal to negative 2 sine of 4x plus 3. Because sine of anything is always trapped between negative 1 and 1, this is trapped between negative 2 times negative 1 plus 3 and negative 2 times positive 1 plus 3. So f of x is going to be between these. I'll have to figure out which one's bigger in a second. So this is 2 plus 3 is 5. And negative 2 plus 3 is 1. So f of x is bounded by the range 1 to 5. Cosine also is bounded by negative 1 to 1. So similarly to what I just did, 6 cosine of 2x minus 8 is going to be bounded by 6 times negative 1 minus 8 and 6 times 1 minus 8. 6 minus 8 is negative 2. Sorry, negative 6 minus 8 is negative 14. 6 minus 8 is negative 2. So g of x is going to be between these included. So it's got a lower bound of negative 14 and the upper bound of negative 2. H of x equals negative sine x minus 1. Again, sine is going to be bounded between negative 1 and 1. So this is going to be 1 minus 1 is 0. It's be negative 1 minus 1 is negative 2. That's clearly smaller. So my inequality signs are going to go this way. h of x, h of x, h of x. And so lower bound is -2, upper bound is 0. Now we've got f of theta is equal to 4 sine of theta minus pi. So we have a formula for sine alpha minus beta, that's sine alpha cosine beta minus cosine alpha sine beta. I'm going to do that here to change this to simplify it. This is going to be, yeah, this is going to be 4 times sine of theta. I don't think that's going to help me at all now that I look at it. So no matter what this, no matter what this angle is in here, sine is going to have to stay between -1 and 1. So my f of theta is going to have to stay between -4 and 4. Let's look at that graph just so you can see it. I'm going to open Desmos to graph it. So 4 of theta is equal to 4 sine of theta minus pi, like that, and it's staying between -4 and 4 because sine of anything is staying between -1 and 1. -1 times 4 is -4, 1 times 4 is 4. So you are going to need to know some of those other identities that I was talking about. Those are going to be more important for the next section where we solve trigonometric equations. This is just an introduction to trigonometry, but I will show you some of those identities while I'm talking about them right now, because they're important. So our fundamental identities are going to be in the form of SOHCAHTOA. The sine of theta is equal to opposite over hypotenuse. The cosine of theta is equal to adjacent over hypotenuse. And the tangent of theta is equal to opposite over adjacent. That gives us the reciprocals of those. Cosecant theta is going to be hypotenuse over opposite. The secant of theta is going to be hypotenuse over adjacent, and the cotangent of theta is going to be adjacent over opposite. We aren't usually going to use opposite, adjacent, and hypotenuse, though. We're going to prefer to use a triangle and an angle in standard position. We're going to say this is X, Y, and R. So Y is going to be in the place of opposite, X is going to be in the place of adjacent, and R is going to be in the place of hypotenuse. So we're going to call this Y over R. We're going to call this X over R. We're going to call this Y over X. Notice how that looks like delta Y over delta X, which is my slope, very closely associated with that. This is going to be R over Y. This is going to be R over X. And this is going to be X over Y. Another set that you're going to want to know for your fundamental identities, besides your reciprocals and your regular definitions, you're going to want to know your quotient identities that say that tangent is equal to sine over cosine, and that cotangent is equal to cosine over sine. You're going to want to know your Pythagorean identities that say that sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared, and that 1 plus cotangent squared is equal to cosecant squared. Those will be important for you. Some less fundamental ones, but also important ones for you to know, especially in calculus, are going to be sine alpha plus or minus beta that I was using just a second ago, that sine alpha cosine beta plus or minus, keep the sign the same, cosine alpha sine beta. Cosine alpha plus or minus beta is going to be cosine alpha cosine beta minus plus, you change the sign there, sine alpha sine beta. That's going to lead us to some double angle identities that say that sine of two, or I'm sorry, I started to write the other side of it. Sine of 2 theta, if alpha and alpha were the same here, would be 2 sine alpha, sorry, theta, switching my variables, 2 sine theta cosine theta, and that cosine of 2 theta, if these were the same here, is going to be cosine squared theta minus sine squared theta. We can use our Pythagorean identities to rearrange here and get everything in terms of sine or cosine. So cosine squared is 1 minus sine squared. So that's 1 minus 2 sine squared theta. Or I could say that sine squared is 1 minus cosine squared, and that becomes 2 cosine squared theta minus 1. All three of those are appropriate. We're going to need to use some of these. You're, before Calculus 2, going to want to memorize your power reducing formulas. Your power reducing formulas tell you that sine squared of theta is going to be equal to, and it's from right here, it's going to be 1 minus cosine of 2 theta divided by 2. And cosine squared of theta is going to be 1 plus cosine of 2 theta divided by 2. Those are going to be important ones for you to know for sometimes in Calculus 1, not usually in Calculus 1. They'll usually tell you to use it in Calculus 1, but definitely in Calculus 2, they're not going to tell you to use the power reducing formula. You're going to have to figure out to use it. That is all of them. There's some sum to product and product to sum ones that aren't as important. There's also even odd identities, that sine is an odd function. So it's going to be like that. Tangent is also an odd function. So it's going to equal this. Because sine is an odd function, cosecant, its reciprocal, is an odd function. And because tangent's odd, its reciprocal, cotangent, is odd. So that leaves, these are all odd functions. The only even functions are cosine and its reciprocal secant. Okay, so those are important. You also have your cofunction identities, which define what the relationship between sine and cosine is, and it has to do with a complementary angle. That cosine of theta is equal to sine of pi over 2 minus theta, and likewise sine of theta is equal to cosine of pi over 2 minus theta, and every pair of complementary functions like that that have the word co has to do with this relationship. So that means that tangent of theta is equal to cotangent of pi over 2 minus theta, and cotangent of theta is equal to tangent of pi over 2 minus theta, and secant of theta is equal to cosecant of pi over 2 minus theta, and that cosecant theta is equal to secant of pi over 2 minus theta. So what we've learned already about transformations of graphs, you should be able to see that there is a horizontal reflection along with a horizontal transformation going on here with these co-functions, and you should be able to take the sine graph and transform it into the cosine graph. You should be able to take the cotangent graph and transform it into the tangent graph. You should be able to take the cosecant graph and transform it into the secant graph and vice versa. So that's what co-functions mean. That's another set of identities. I think that that is everything that I can remember that you need to know for calculus from pre-calculus. Let's go ahead now and use the unit circle to help us answer these questions 15 through 18. Find the ordered pair for the point on the unit circle associated with 5 pi over 4. So 1, 3, 5 pi over 4 is down here. That's going to be negative root 2 over 2, negative root 2 over 2. Sketch the unit circle and the angle represented by theta equals 7 pi over 6. So that's 30 degrees below the x-axis down here. Find the ordered pair. This line intersects the circle. So sine is going to be negative 1/2. Cosine is going to be negative root 3 over 2. And we're done. Find the equation of the line that intersects the circle at theta equals pi and at theta equals pi over 3. Answer in slope intercept form. So, okay. Got at theta equals pi over here, we've got the point negative 1, 0. At theta equals pi over 3, up here, we've got the point 1/2 root 3 over 2, and we've got a line that comes through those 2 points, and they want us to find the equation of that line. So our slope is going to be y2 minus y1 over x2 minus x1 is going to be root 3 over 2 over 3/2 is going to be root 3 over 3. So then I'm going to take this point, negative 1, 0. That's easier for me to deal with. So I'm going to say y minus 0 is equal to m times quantity x minus a negative 1 is plus 1. They said to write this in slope intercept form. So there's my answer, and I'm done. I think that that was all of my, that's all of my questions for this section. So next time we're going to come back and look at more trigonometric functions and triangles, and we're going to try and probably solve some of those things. All right, see you next time.